I want to talk about simplification today. And I want to start with the idea that we cannot simplify sums. We cannot start canceling off numbers and say 6 divided by 2, which is 3. Can't do this. This is not true. All right? We can only cancel factors. All right? And factors means we have to make a product. So I look at number 1 and I have no products. I look at the bottom and there's nothing common. But when I look at the top, the numerator, I see that there's 5 and 50. 5 is common. So I can take out the greatest common factor of 5. And I can rewrite the black expression for number 1 as the red expression because they're equivalent. The denominator is obviously the same, but look at the numerator. Is 5v plus 50 equivalent to 5 times v plus 10? The answer is yes. And again, v plus 10 is one thing. Are they exactly the same? Yes, so the whole thing cancels because they're going to be the same. And I get the value of 5. I can do some quick double checks to make sure I'm right. I can pick a value, say, of 2 for v. V equals 2. And I could say 5 times 2 plus 50 over 2 plus 10. 10 plus 50 is 60. 60 divided by 12. Is that 5? The answer is yes. And that would prove I'm correct. And you can do that every time because I had 5 here and I would get 5 here for v equals 2 on both values. This always simplifies to 5. So if I move down to number 3, and again, we've got to make products. I have sums. There's nothing I can cancel here. Nothing is the same. There is nothing common in the numerator. What's common in the denominator? I should be able to see that 8 is common. And again, if you pull an 8 out, you get the 8 times b plus 4 is equivalent to 8b plus 32. You distribute this, you should be able to see that the denominators are equivalent. Again, I take a look at what's exactly the same. The numerator has b plus 4 as one thing. The denominator is b plus 4. And we have to see that when we cancel, there's going to be a 1. And the answer to number 3 is 1/8. Again, take a look at number 4 now. Nothing common in the top. It is a factor. It could cancel. But on the bottom, it is a difference. You can't cancel a difference. You have to make it a product. So you have to look at what 49m squared and 42m have in common. Hopefully you see there's an m in both. The 49, again, has a 7 and a 7. This has a 7 and a 6. So pull out the 7m. And that leaves 7m minus 6. 7m times 7m is 49m squared. 7m times negative 6 is negative 42m. The denominators stay equivalent. Now, if it helps you, there is one thing we can do here. We can actually break this into factors. 7 times 5 times m times m. If that helps you see this problem, go ahead and do it. That is still equivalent. Because what I'm looking to do now is say, hey, everything in the top is a factor. I can do this. Or you can say 35 divided by 7 is 5. M squared divided by m is m. Our answer to number 4 is 5m over 7m minus 6. Five and 6. If you want to pause the video and try these, I'm going to, again, make them factors first. You can't do anything until they're factors. And I see that 56k comes out of the top. And I see the bottom is 64k squared. And again, this is a time where maybe it would help for us to write 56 and 64 as factors so we see this. So 7 times 8k times k minus 1 over 8 times 8 kk. And again, now you have factors, 8k, 8k. And I'm left with 7 times k minus 1 over 8k. You can redistribute this, 7k minus 7. But here is our simplified solution for number 5. Again, number 6, there's a sum in the Denominator, you have to make it a factor. I see 4n being common. Again, make sure they're equivalent. And this time I'm not going to, well, I'm not going to reduce. I'm going to go n, and that takes care of one of the n's. 14 divided by 4. Well, that is equivalent to 7/2. So my answer is 7n over 2 times n plus 1. And again, you can distribute this to n plus 2, but I'll leave it as the factors. 7 and 8. Last two. No, I'm sorry, they're 10. 7, 8, 9, 10. Number 7. Again, I have to write the denominator as a factor, which is equivalent because that's where the sum was. 35 divided by 5 is 7. This is 7. Over here, number 8, x minus 10 on top. It's a difference. Again, is anything common? The answer is no, so I'm stuck with it. I'll leave it as x minus 10. On the bottom, what's common? How about 8x? And again, a lot of times you'll say, hey, it has to be x minus 10 if anything's going to cancel. The answer is yes. So I end up with x and 10. Does that work? The answer is yes. The top is x minus 10. They are the same. I cancel, realizing there has to be a 1 left on the top. 1 over 8x. Problem 9 and 10. Again, I see r plus 3, it's a sum. I'm looking for a factor, but nothing's common. 6r plus 18, but here we should see the 6 is common. So I put r plus 3 on the top, and I get r plus 3 on the bottom. And again, they're common. And when you cancel, you get a 1 on the top. Don't forget the 1. Don't write 6. 1/6. Problem 10. Again, 2's differences, all right? So you have to factor. I always write with the variable first. So I'm going to rewrite 10 like this first. And you should want to too. Because you're not going to be able to simplify this one unless you do this. You see the 4. So you take that. And right now, nothing is exactly the same. Negative n plus 6 is not the same as n minus 6. But you got to remember, you can factor out the negative on the top. I can factor out a negative 1. And if I do that, negative times n is negative n. Negative times negative 6 is positive 6. Well, now they're both exactly the same. If I cancel these, I get negative 1/4. Number 10 is by far the hardest and the one that needs to be practiced the most. And again, you have to write things in descending power. Simplification requires factors.